we see the law of parallelogram of forces. Law of parallelogram of forces, I have already explained that. Suppose there is some rigid body and there are points that are known as the particles. In the last period, I have defined what is the particle. It is the smallest part of the rigid body which has a small size and mass. Now, suppose that there is some point and there are two forces acting on this point. So we take that point nothing but the O. Suppose we take this point as O. And there are two forces acting on this particular point, that is force P and Q. Both forces has a different magnitude. The magnitude of is first force is given by P and magnitude of the second force is given by Q. And direction of these forces are different. These two forces acting at a point can be represented by using the parallelograms. Now you can construct this parallelogram OA, OB, AC. We can extend these sides and you form a parallelogram. This is a diagonal to the parallelogram. Now using this, I can write a law of parallelogram of forces. What is the law of parallelogram of forces? If OA is equal to P bar, OB is equal to Q bar, and OC is equal to R bar, then R bar is equal to P bar plus Q bar. This is the law of parallelogram of forces. Now, how to prove this law? It is very simple. Just to consider OC bar is equal to OA bar plus OB bar. Means the two forces acting at this point can be added in this way. Either two sides of this, two forces indicated at the point O and can be written like this way. But we know that according to the parallelogram, OB bar is parallel to AC bar. Means OB bar is, what is this thing OB bar? OB bar is Q bar, means this is the Q bar. Now OC bar will be equal to, we can replace this OB bar by AC bar. Now this become OA bar and AC bar. So R bar can be written as P bar plus Q bar. Now this R bar is nothing but OA plus AC bar. You can see from the figure, and this is the proof of law of parallelogram of forces. So we just write a simple law, that is law of parallelogram of forces acting at a point with a different magnitude and different directions. Okay. Now we in the next part we see the next part. We have seen in the law of parallelogram of forces that at the point O there are two forces acting at this particular point, that is P bar and Q bar, and whose resultant is given by the R bar. Now we just see how to calculate the magnitude of the resultant and direction of these two forces. Now we first calculate the magnitude, that is determine the magnitude and direction of the given resultant R bar of two forces, that is P bar, Q bar, acting at an angle theta. Means angle between these two forces is theta. Now we have to find what will be the resultant and what will be the resultant will make angle with the first forces. Now we first find out the magnitude. How to find the magnitude? We have from the law of parallelogram of forces, R bar is equal to nothing but P bar plus Q bar. It is indicated by equation 1. Now we multiply this R bar with this. We take the vector product for this. Now in this vector product, we just have P in the place of R we replace P bar plus Q bar, the product R bar. Now we again replace in the next line value of R bar. Now we take the product of these two brackets. Now this product will be R bar. This is the vector product R bar with the R bar. Now this P will be act with this, P will be product with this, and you can take one by one term to term product, and you will find that OP bar plus OP bar, similarly the terms and everything. Now we have from the relations that if you have vector product of 2, then you can replace it by mod of R bar R square, similarly for P force, similarly for the Q force. And it is also indicated that this is associative in nature, therefore we can write O bar equal to P bar plus Q bar. This associative is indicated here. Now this relation becomes mod R bar is equal to P bar. Now this product, this vector product, so I can write like this way, P bar plus Q bar cos theta, and that is q bar square. Now we get the we take the under root of both sides. If you take the under root of both sides, you will get resultant is nothing but equal to resultant is nothing but equal to, it is indicated here, it not need to write here. Okay. Now r is equal to under root p square plus q square is equal to 2 pq cos theta. This is the resultant of the two forces acting at this particular point. Now we see how to calculate the direction of the resultant. Okay. Now we find the angle made by the resultant with the first force P bar. Now for that we just draw a perpendicular from C to the line, extended line from OA, that is mid in M. Now this OAB angle OABOA and angle CAM means this angle and this angle are equal as per the rules of the angles. Now R makes an angle, R makes an angle with alpha with the direction of P bar. Now from this, and now you consider CMO. This is nothing but a right angle triangle, and in this right angle triangle, if you consider the tan of alpha will be opposite side upon adjacent side. Now opposite side is CM and adjacent side is OM in this triangle particularly. If you consider, you will find that opposite side is nothing but CM and the adjacent side is OM. Now CM is equal to, you can consider CM in this particular, you can, these are the two parallel sides. You can consider this particular right angle. In this right, you consider the cos of theta. Cos of theta will be q. And this side here particularly, this side is q, here q, and this is am. You can consider the cos of theta here also. Sin of theta. Sin of theta is nothing but opposite side upon opposite side is cm upon this AC. Now this is just equal to cm will be just equal to AC into sin of theta. This is q, that is q into sin theta. Q into sin theta. You can substitute here also. OM will be divided into part OA plus AM. It is given here. M is equal to AM plus AM. Now you can consider AM. How to find the AM? AM will be found like this way. Cos theta is equal to CM upon AC. Because you can consider this right angle triangle. CM will be equal to AC into cos theta and CM will be equal to Q into cos theta. You can replace this value here. According to this equation, if you substitute the value and take alpha is equal to, take the inverse of this tan, and you will find that this will give the angle. If you know the just angle between these two forces, and the magnitude of the two forces, that is P and Q, you can find the angle made by the resultant with the first force, and hence we have determined the magnitude and direction of resultant if the force at particular point. Okay. Now there are some deductions we will see in the next period.